Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the Pythagorean theorem and how the Pythagorean theorem can help us find missing side lengths of right triangles. Before we do, let's review the parts of a right triangle. In this image, we have a right triangle shown, and in the bottom right corner, you will see 4 vocabulary words pertaining to right triangles. Pause the video and try to fill in each blank with one of the vocabulary words. All right, welcome back. Let's see how you did. Here you should have put the hypotenuse, is the longest side of a right triangle, and it is always opposite the right angle of the triangle. Now, the 2 sides over here on the left are called the legs of the triangle. Usually there will be a shorter leg and a longer leg, but it is possible for the 2 legs to have the same exact length. Okay. This angle is 90 degrees, and it's also called a right angle. So take a minute and check your work to make sure that you put the proper vocabulary term into each blank. Now, in that problem, our right triangle was oriented so that it was fairly easy to see the legs and the hypotenuse. But when you're working and solving problems with right angles, the triangle will oftentimes be turned or rotated in such a way that it's sometimes harder to tell which side length is the leg and which side length is the hypotenuse. So in example 1, I want you to practice finding the hypotenuse of each triangle. So you're going to label the hypotenuse of each triangle below by putting an H on the side representing the hypotenuse. Pause the video and try this example on your own. All right, welcome back. I'm going to put an H on each hypotenuse so that you can see how you did. For example A, I put the hypotenuse here. For example B, I labeled this side the hypotenuse. For triangle C, I labeled this side with a capital H for hypotenuse. On triangle D, I labeled this side with a H for hypotenuse. And in triangle E, I labeled this side with an H. So in each triangle above, how did you know which side of the triangle the hypotenuse was? Take a minute, think about that, jot down your thoughts, and pause the video. All right, welcome back. Did you put something like the hypotenuse is always the side opposite of the right angle? So if you put something like that, you would be correct. Now, we have a very, very famous theorem in mathematics called the Pythagorean theorem. It's an ancient theorem, actually, that says if the lengths of a right triangle are given by A and B, and the length of the hypotenuse is given by C, then the following equation is always true. The leg squared plus the leg squared is equal to the hypotenuse squared, or with variables, A squared plus B squared equals C squared. So in example 2, it says, consider the right triangle shown below with legs A and B and hypotenuse C. It says if the value of A is equal to 6, so let me label that, and the value of B is equal to 8, let me label that, find the value of A squared plus B squared. So when we're evaluating an algebraic expression, the first thing I usually do is replace each variable with parentheses. Then I plug in the proper values. So for A, they told me the value was 6. And for B, they told me the value was 8. Now, you could do this mentally, or you can use a calculator. I'll show you how to put it in your calculator. This is Desmos, by the way. 6 squared plus 8 squared, and that would give me 100. So that is the value of the expression a squared plus b squared. Now, in problem B, it says if the value of c is 10, so let me label that as a 10, find the value of c squared. So this time we're evaluating the expression c squared, so I'll replace the variable with the parenthesis, and into the parenthesis I'll plug in the given value, which in this case was 10, and 10 squared, I don't even need my calculator for that, is 100. So that proves that the given triangle is a right triangle because a squared plus b squared is equal to c squared. Now, the most straightforward application of the Pythagorean theorem is finding the length of the hypotenuse if you know the lengths of two of its legs. These calculations always involve square roots, so sometimes the lengths are irrational and we must round our answer. So if you get a square root like this, that is considered rational, and we would not need to round our answer because square root of 25 is 5. But if I would have gotten something like this, square root of 26, that's considered irrational. In cases like that, when we work our problems, we'll be rounding our answers. So you will just type in a square root symbol, type in the number, and then you'll round, in this case, to the nearest tenth. So it would be approximately 5.1. Okay. Now, in example 3, it says for each right triangle below, find the length of the hypotenuse using the Pythagorean theorem. If the length is irrational, round to the nearest length. Now, I'm going to correct the instructions here. I believe this should say find the missing length. So we'll just be finding our missing length. Now, when working with the Pythagorean theorem, the first thing you need to do is make sure you have a right triangle. When I was a student first learning the Pythagorean theorem, I assumed that the Pythagorean theorem worked on all triangles, but it only works on right triangles. So as you can see in problem A, we have a right angle clearly marked, so we know this is a right triangle. So what you want to do first is label your A, B, and C. Now, usually what I do is I label the smallest side A and the medium side B, and then the side opposite the right angle, I'll always put a C on, okay? Sometimes it's hard to tell which is the smaller side, but don't worry about that because the legs are interchangeable. So if I was going to use the Pythagorean theorem here to find the value of C, I know my answer has to be bigger than 6 because the hypotenuse is always your largest size. So I'm going to write down my Pythagorean theorem, a squared plus b squared equals c squared. And then I will replace my variables with parentheses, except c, because we don't know c. All right, so I will plug in our given values. A was 3 and b was 6. Now I'll come over here to my calculator and I'm going to put in 3 squared plus 6 squared. So the value of a squared plus b squared is 45. So I know 45 is equal to c squared. Now, I don't want to know the value of c squared. I want to know the value of c. So to find c, I would just take the square root of both sides. So the square root of 45 would be, if I rounded it to the nearest tenth, 6.7. So 6.7 units. I should put approximately because we did round it, is the value of C in this problem. All right, look at problem B. Let's begin by labeling our right triangle. First off, I want you to label the hypotenuse because the hypotenuse is the side that's opposite the right angle. So we know this side has to be C. This side looks to be our smallest side, so I'll label it A. This side is B. So in this problem, if we use the Pythagorean theorem to find the length of side B, we would say a squared plus b squared is equal to c squared. Now, they've given us a value for a. We do not know the value of b, and they've given us a value of c. So I'll replace the a and the c with parentheses, and then I'll plug in what I know. I know a is 2.7. I know c is 6.5. Now, to solve for b, I'm going to have to subtract this 2.7 squared from both sides. So this would go to 0, and I'd be left with b squared equals 6.5 squared minus 2.7 squared. So let's put that in our calculator. 6.5 squared minus 2.7 squared. So 34.96. So b squared is 34.96. Now take the square root of both sides to find the value of b. So square root of 34 would be approximately 5.9 units. All right, problem C. We have a right triangle. Let's start off by labeling our sides, and I always want to start off with the hypotenuse. So the hypotenuse is the side length across from the right angle. So I'll put my C there, and I'll put an A here and a B here. All right, so we have A squared plus B squared equals C squared. So I know A and B, so I will replace them with parentheses. I do not know C. So for A, I'm going to put in a 2.7. For B, I'm going to put in a 6.5. All right, so 2.7 squared plus 6.5 squared is 49.54. And by the way, don't round here. Do not round until your final step. So A squared plus B squared is equal to 49.54, and that's equal to C squared. Now, to find C, just take the square root of both sides. So square root of 49.54, and we will round this to the nearest tenth. So C would be approximately 7.0 units. All right, problem D. We have a right triangle. I want to start off by labeling the hypotenuse. So in this problem, C is 13.3. I'll put this side as A and this side is B. So we do not know A, so I'll put A squared. I do know what B is, so plus 9.7 squared. And I do know what C is, so 13.3 squared. Now, to get A squared by itself, I'm going to have to subtract 9.7 squared from both sides. So A squared will equal, this zeroes out. Over here, we have 13.3 squared minus 9.7 squared. And that gives us 82.8. And then take the square root of both sides to get the value of A. So A equals square root of 82.8 gives us approximately 9.7 units. All right, pause the video and try problem E and F on your own. All right, welcome back. Let's see how you did. On this one, I labeled this as a C, and I knew that A was 2 squared plus 7 squared has to equal C squared. So 2 squared plus 7 squared gives me 53 is equal to C squared. Then I took the square root of each side, and the square root of 53 was approximately 7.3. So C was approximately 7.3. Take a minute, check your work, and see how you did. Correct anything that you might have gotten wrong. All right, on problem F, I labeled this side as C because it was opposite the right angle. This side is A and this side is B. So that means 6.5 squared plus B squared is equal to 9.9 squared. Now, to get the B by itself, I have to subtract 6.5 squared from both sides. So B squared would equal 9.9 squared minus 6.5 squared. And that gives me 55.76. Now taking the square root of both sides will give me an approximation for side length B. So square root 55.76 gives me approximately 7.5 units. And that concludes today's lesson, Introduction to Pythagorean Theorem.